Greetings, welcome to Machine vs Mathematics channel. Here we have a simple and decent question asked in GATE ECE 2014, set to 2 for 2 marks. See, the diode in this circuit has this cut-in voltage or on voltage as 0.7 volt. Okay, now input voltage, if this input voltage is AC quantity given like this 5 sine omega t volts. Now in this scenario he is asking us to find the minimum and maximum values of the output voltage V0. Okay, you have four options, four simple options we have, so we must be able to do this. See, for example, now let's go for this. The same circuit, yeah. Anyone who can tell this? This node voltage is not across this 1 kilo ohm. Yes or not? This node voltage is across, this node voltage V0 is across this combination. Yeah, 1 kilo ohm, this diode. Yeah, this on voltage is 0.7 volt given and 2 volt. So always node voltage we should take with respect to ground. Yeah. So therefore the node voltage with respect to ground, yeah, is V0. So therefore V0 is across this combination, please, not across this 1 kilo ohm. Okay, so therefore this circuit is identical to this. Okay, the same circuit is identical like this. So let me redraw this circuit to make things simple. Okay, I have Vi here, this is my Vi. So I have 1 kilo ohm and this one is again 1 kilo ohm. The on voltage is given to you 0.7, so we will decide this. So you have 2 volts, so I will take some 2 volt. Anyways, 2 volt is our DC source, so we can take like this. Okay, and now this is your voltage across. So this fellow, so he must be our output voltage. So this 1 kilo ohm is this. So 1 kilo ohm. And this is again 1 kilo ohm. Okay, now we will start our process in solving this. Now anyways, as it is a sine voltage, so check with positive half cycle. So check with positive half cycle and negative half cycle. Okay, in positive half cycle, how things are acting, I mean things means how diode is behaving. And in negative half cycle, again we have to see how diode is behaving. So based on that we can find out minimum and maximum values for this voltage V0. Okay, now if I take Vi is equal to say 5 sine omega t. Okay, that means my Vi is this, my Vi. So I have a sine function, like this. Okay, say this is my 5 sine omega t and this is positive 5 and this fellow is negative 5. Okay, and that's it. So assuming that we have sine like this, from t equal to 0 we have this sine. Now what happens if I take a positive half cycle of our sine wave? Okay, that means if my Vi, if my Vi is positive 5 volts, if my Vi is positive 5 volts, because for positive half cycle of sine I have positive 5 volts here. So therefore let me write it down like this. For positive half cycle, what is my input voltage first? My input voltage is positive 5 volts. Okay, now input voltage is positive 5 volt. That means if it is positive 5 volt, this diode must be, this PN junction diode must be on, because anode is made positive. Anode is more positive than cathode. I have 2 volt here and this anode is made more positive than cathode, so therefore this diode is forward biased and hence current will flow through this circuit. Yes or not? So therefore Vi is positive 5 volt. So therefore my diode is forward biased. Yeah, so if it is forward biased means this diode is on, so therefore we have current through this circuit. So if diode is on, we have to take on voltage equal to 0.7 volt. Okay, so on voltage equal to 0.7 volt, otherwise ideal. Okay, otherwise I can assume ideal conditions. So anyways this diode is on, so I will take on voltage as 0.7. okay, so let me take another page. Okay, so let me put it down like this. Now for positive half cycle, I have V input is equal to positive 5 volt. Alright, so I have 1 kilo ohm here, and I have one more 1 kilo ohm. So make your circuit as simple as possible. That's it. Okay, so now as diode is on for positive 5 volt, so on voltage is given to us 0.7 volts, so we will take it as granted. So this is my 0.7 volt, and you have 2 volt here. Okay, so this is 2 volt as it is, and on voltage is 0.7 volt. Okay, now how current is flowing through. Now for for positive 5 volt, this is my source, so therefore you get like this current. All the way current has to travel down the circuit like this. Okay, now what is I here? How to find I? So this I is equal to simply 5 minus 0.7 minus 2 divided by, what do we have here, 1k plus 1k, this is 2 kilo ohms. Okay, so if you find this, you will get 1.15 milliamperes. So I is equal to 1.15. see, newcomers, you can apply KVL if you want to know how to get this conservation of energy in a loop. So see, for example, let me go like this. Let me take clockwise because we have this current flow this way anyways. Okay, now see, I'm going from minus to plus, achieving something, so take positive 5. So VI is positive 5. Now see, now again current always enter at plus, exit at minus. Now what happens? Okay, so this is what voltage across 1 kilo ohm. Okay, what is voltage across 1 kilo ohm? I multiplied by 1 kilo ohm. Now I'm going from plus to minus. I'm going from plus to minus, losing something. So therefore minus 1 kilo ohm multiplied by I. Okay, again current always enter at plus, leave at minus. See, now what happens here? Again I'm going from plus to minus, so voltage drop across this 1 kilo ohm is again, see, as I'm going from plus to minus, say losing something, so therefore I'm taking negative. So 1k multiplied by I. Again this is plus minus. Okay, so now current is entering at plus, leaving at minus, so assume losing something, so again minus 0.7 volt. Again current entered plus, leaving at minus, say again losing something, assume like that, this is minus 2. Okay, end of the day there must be conservation of energy in the loop. So therefore now what you get, so 5 minus 0.7, so this is 4.3 minus 2. So you find this, everything you find, again you will get same answer, 1.15 milliamperes. So there is no big deal in this. Okay, now what is output voltage V0 here? So anyways output voltage is this. So anyways output voltage is this one. So I can find output voltage like this. This is my V0. Again you can apply KVL. See, anyways the direction of current is like this, I can apply KVL. Okay, like this, then you would get, okay, then what is V0 here? As we have I. Okay, so I multiplied by 1 kilo ohm, now plus 0.7 plus 2. So if you find this, you will get 3.85 volts. Okay, otherwise if you have doubt, newcomers or any second years or first year students, if you have doubt in solving this, now let me take this part of my circuit. This part of my circuit, you can just play with your circuit. Circuits are fabulous, and they really help us in solving things. So yeah, and I have V naught like this. So let me take, see, anyways, direction of current is like anti-clockwise, so there is no second thought what is there. So this must be plus, and minus, this is V naught. So direction of current is like this mentioned here. So I is going all the way this way. Now you have 0.7 volt, and this fellow is 2 volt, and he is Mr. 1 kilo ohm. Now already we have I is equal to 1.15 milliamperes. So therefore I am going this way now. Okay, now see what happens. I am going from minus to plus, achieving something. So therefore I take positive V naught. Current always entered plus, leave at minus. So I'm coming from plus to minus, say losing something. So minus 1 kilo ohm multiplied by I, and again current will always enter plus, leave at minus. So therefore assuming again losing something like, okay, and again current entering at plus, leaving at minus. This is minus 2 equal to 0. So if you take and if you put I is equal to what? I is equal to 1.15 milliamperes. You must get again same answer. You can check things out. Okay, V naught is equal to this. So in the option maximum voltage we have this one. See, C must be correct answer. So you have 3.85 volt here. Luckily you have like this. Okay, so now definitely option C must be correct. So this is maximum voltage. So this is V naught max, and that means this must be V naught min. See, it is very simple to find minimum output voltage. Why? You see, for positive half cycle we got maximum voltage as 3.85 volt. Now if I take negative half cycle, negative half cycle means what? This Vi becomes negative 5 volts. Okay, see, Vi becomes negative 5 volt. If Vi is negative 5 volt, now anode is less positive when compared to cathode. Okay, negative 5 volt. Okay, so if I put negative 5 volt here, this fellow is less positive when compared to cathode, and hence diode becomes reverse biased. Okay, so when diode is reverse biased, there is no current in the loop. So there is no current in the loop. So therefore entire input voltage must appear across these terminals. So that means V naught is equal to Vi. So Vi is equal to negative 5 volt. Simple. Yes or not? So that's it. So Vi, that means V naught is negative 5 volt for this. So let me, if you want, I can solve things here. See this circuit, we formed it this way. Now for negative half cycle, focus on this. For negative half cycle, now what is Vi? Vi is negative 5 volt. Let me use this place. So let me use this place. So now Vi is negative 5 volts. So this is Vi. So this is Vi. So I'm giving a negative half cycle. So therefore Vi is negative 5 volts. This is my Vi. Okay. So this is negative 5 volt for Vi, and you have okay, so 1 kilo ohm here. Anyways, I have 1 kilo ohm. This one is done. Now this fellow, there is 1 kilo ohm again. There is 1 kilo ohm again. Now what happens here? You see. So as this is negative 5 volt, if I take this one as a negative 5 volt, so here I have less positive when compared to this. So therefore diode is reverse biased. So there is no current now. It is open. Whether there is 2 volt source, whatever, there is no meaning now. Okay, so see, as okay, I can take this way. Negative 5 volt means I can take like this. This is my negative 5 volt. So there is no current in this because it is open here. So there is no current in this. So therefore there is no current, there is no drop, nothing. So whatever voltage I have here, so whatever, see, there is no current. That means I can write like, I can take like this, I is equal to 0. So as there is no current, there is no drop across this 1K. So if this is open, so there is no meaning of this entire branch here. You can remove this entire branch. Okay, you can remove the entire branch. Now this is my V0 here. So V0 is Vin. So this is my V0. This is my V0. So V0 is equal to Vin. But what is Vin? Vin is equal to negative 5 volt. So therefore, for negative half cycle, Vi is negative 5 volt and V0 is again same as input, that is negative 5 volt. Okay, so therefore correct option is option number C, minus 5 and 3.8 volt. That's it for today. So this is simple and interesting question as well. So whenever you're given this kind of questions, if you have doubts, please try to again redraw your circuit in your convenient way. Then you can try to solve. Definitely things will help out. Okay, node voltage must be always with respect to ground. That you have to understand in the initial run. Then you can do things very well. Okay, thank you.